Welcome back to Cloud 42, I'm James. This is the last part in the hand scraper build video series. Today we're going to make the threaded steel insert that locks the plastic handle onto the scraper shank, and if we have a little bit of extra time we'll do some engraving. This is a drawing of the part that we're going to make today. It is just a simple cylindrical piece of turning with a smaller diameter to fit down into the handle and then a larger register to catch the back of the handle. You can see the way the handle is printed. Actually, I'm not sure if you can see that very well. There's a bore through down to where the tang of the scraper shank is going to be, and then there's a little register around the inside of this, and this head is going to grab that register and suck the handle down onto the scraper shank. So it should be some simple turning. We need to drill through and tap this quarter 28, and I marked the drawing at quarter 24 apparently. It's quarter 28, and we probably won't try to drill all the way through this just because the drill bit is going to wander a little bit. It's just the nature of drills, so we're probably better off drilling half of this from each side and then tapping from each side. And then the last operation is going to be to go over to the mill and cut the kind of screwdriver slot in this with a slitting saw. This is the material I'm going to use. I thought about using tool steel or silver steel, but it really doesn't matter in this application. It doesn't have to be that strong. It's not going to be continuously assembled and disassembled. And if I'm wrong about that and someday it ends up wearing out, well, we can make another one and we can go ahead and use tool steel then. This is just 1018 cold finish steel. This is 3/4 of an inch because the largest diameter here is 670 thousandths. So let's take this over to the lathe and get started. Okay, the stock mounted here in the lathe. Let's see, how far out does this need to stick? We've got a little over 2 inches, or a little under 2 inches apart, so a little more than 2 inches of stick out should be fine. Okay, let's see how that spins. Okay, that looks pretty good. Let's face the end and turn a section of this to diameter so we can get a measurement. Okay, that's going to be plenty, and the diameter we're trying to go to is 670. And we're currently at about 711. So we only need to take about 20 thousandths more per side, and we will be there. This is not a real precise diameter for the head of this thing. I'm going to take the speed up a little bit more, try to get a good clean cut here. You're looking for 670, where did we end up? 671, that will be just fine. There's no reason to go any more than that. Okay, the shoulder length on this is 1.685. So let me use calipers to mark this. Lock that down at the dimension. Little blue Sharpie. And a nice mark right where we're trying to go. I'm going to go up and make that mark really clear and obvious. Okay, so when you take 100,000 off of each side, I'm going to start with a cut of 30. And we'll just see how this goes. Make this 60. Okay, we should be at 470. 472, 471, 470 even. So that is exactly what you'd expect with this much unsupported material, but an extra thou lost on each side of the clearance is not going to be a problem at all. Okay, let's check the length of this thing. Shoulder's supposed to be 1,685, but of course I cleaned it up. I cleaned up the shoulder, which is going to affect that. $1,689. So 4 extra thousandths on there, not going to hurt anything. Especially on the length measurement, it's just not going to matter. Okay. Let's put a little chamfer on a couple of those edges. I gotta say, I am loving the variable speed on this lathe. So I can go from just flying with the carbide down to just barely crawling for something like a high-speed steel chamfer. Okay, let me grab some drills and let's put a hole in it. Just spotting here with a small center drill. Now let me grab a number 3, which would be tap drill size for quarter 28. Okay, number 3 drill. Okay, let's chamfer that. Okay, nice lead in on the end. Now let me grab a tap. Now see if this chuck can hang on to this tap all the way in there. Got plenty of oil on it. Slowest speed. And let's see what it does. Oh, I am loving the variable speed. And that's it. And that is just gorgeous. Okay, so to do the other side, I am gonna take this out and walk it over to the saw. I just left it on the parent stock, so we'll just take this over to the saw, cut it off, and I'll be back in a minute, and we'll do the other side. Okay, here's the part back from the saw. I just cut that off, and let's get it mounted. Now, I am using a 3-jaw chuck here, so it's not going to be perfectly concentric, but it's going to be close enough for this application. The concentricity doesn't really matter. I've already got the internal threads in the point and both of the diameters concentric. The only thing that might not be concentric is the hole that goes in this end, and that's not going to be used when the part is turning. That's just going to be an anchor point for accessories on the back of the scraper, so it's not going to matter even if it runs out by a few thousandths, which it definitely is. Now, I'll be honest with you, this is the second one of these that I made, because the first one I completely scrapped. I got to this point and thought, okay, now I'll just turn this outside to diameter, took a cut, took a measurement, and then realized I already turned that outside to diameter in the other setup. So all we need to do is face the head to length, chamfer, drill, and tap. Okay, we're headed for 165, so I'm just going to open this up to 165. And then zero it, and now just measure the head. So we have 100, it says 157, 156, we have 156 thou to go. So let's take 50 at a time. There's 50. Now zeroing this out again. 164.5, I will definitely take that. Beautiful. I'm spotting it very gently and just sort of pecking in several times, trying to make sure that it's just as centered as possible. And get the lathe to average out any tailstock error I've got by kind of scraping with the tip of the drill. I'm going to do exactly the same thing, scraping gently until I'm sure it's running true. There we go. Okay, just going to do a little bit of cleanup on this head with Scotch-Brite to make sure everything's pretty after I get the tap out of the way so I don't cut myself on it. Okay, it's nice and bright. I like it. Okay, the last thing we have to do is take this over to the mill and put a slot in it. Okay, we just set this part up in the vise so that we can cut a slit across the face. I've got a slitting saw in here. Let's get set up here for the cut, drop in a couple of parallels, and I think I'm just going to put the part back. I'll probably hold it slightly off the vise jaws just because there's a small radius there in the edge, in the corner there. Now this again might put some marks on the side. I don't care that much because that part's not going to be visible. Okay, next thing we need to do is get the height correct for the slitting saw. There's lots of ways to do this. But what I'm going to do is just touch off. So I'm going to bring the blade slightly over where it won't really cut much, but it'll make a little bit of noise when it touches. And then I'll spin it up slowly and then bring it down until it just touches. And I'll judge it by the sound. Okay, we're going to call that touched off. So now I'm going to zero my Z, and I need to bring it down half of the diameter of the part and half of the diameter of the cutter. So the part is, according to the drawing, 670 thousandths, so 0.670, plus the width of the cutter, which I believe is 40, for a total of 710 thousandths, divided by 2, 355. So we need to bring it to Z of negative 355. Make sure I'm not going to hit anything. Nope. 2, 3, 3, 4, 350, 354, 9. Okay, that's good. Now, does that look centered? Boy, that looks completely centered. Okay, next thing we need to do is figure out how far to push it in, and we need to go in 50 thou. So again, I'm just going to spin it up slowly, and I'm going to bring it in until it touches. There it is, just touching. So now we'll zero my X. Now I'll come forward because I want to do a conventional cut through this, and then I'll bring the X in 50 thousandths. Okay, I think we're ready to make the cut. Let me get some coolant going and get this at a reasonable speed. Well, that is quite beautiful. I'm entirely happy with that result. Let's get it out of the vise and take it over to the bench and put it together. Okay, as long as I'm set up over here on the mill, I want to go ahead and do a little bit of engraving. I want to put a little ramp. I'm going to try something I've never tried before. I'm going to put a little ramp on the back of the clamp here and then actually engrave maker's mark on that ramp and the date up just above it. Yeah, you know I'm going to indicate that, right? Okay, that's nice and solid. Here's a close-up of the engraving. You can see there's my maker's mark, Cloud 42, and then the date, 2018. Because these are at different angles, it's kind of hard to get them in the right light. But it's pretty nice. I'm really happy with the way that turned out. It did raise quite a burr, going 5,000 deep with that little D-bit that I ground up. And so I stoned this to bring it down, and then actually smoothed out a little bit of the ridges from the profiling, and I'm very happy with that. Let's put the handle on this thing and see how it all goes together. Okay, got the hand scraper here ready to fit the handle. This is the threaded insert that we just made. Let's just make sure that that threads on as expected. And it does. That's perfect. Okay, I have both handles here that I made earlier. This is the second one that sits a little bit deeper, and let's see, set that all the way down. Now I think that, as I said before, I think that's sitting a little bit too deep, and I'm going to want to make another one that sits out a little bit more. Let's put the insert in here and see. And try not to scrape this up. Yep, and the insert has now bottomed on the end of the tang, and hasn't quite met up with the handle yet. So the handle is actually loose. So you can see the handle's actually loose on there with this bottom. So that one is a little bit too deep. Let me pull this out. Okay, let's try the first handle we made, the one that wouldn't go on far enough. So that's not down as far as I'd like, but let's see how far we can draw it down with the insert. And the insert will grab, looks like maybe 3 threads. Let's see how far we can draw it on. It is drawing down. I don't really have a screwdriver big enough for this. I might try to make one at some point. That sounds like an interesting challenge. Okay, so it's getting tighter, so it is deforming the plastic as it pulls down, which kind of was the plan originally. It's just a matter of how comfortable am I taking it, how far. That's pretty close. That's probably, oh, that's about a 1/16 of an inch, about 60 thou from where I want it to be. And there, it's getting pretty stiff. You know what? I'm going to call that good. I was thinking I was going to have to go make another one. But I think that is going to be great. And I've got a nice flush fit here on the back end. Coming up to the insert. Does the insert clear the plastic? Oh, and it does, all the way across. Very nice. Let me get a screw. 1/4 28 screw, and this is what we would use to attach any accessories to the back of this. That is beautiful. Okay, that is a hand scraper, and I'm very happy with that handle. Oh, and with that in the back, there's no sharpness there. I can push very easily on the back because it meets up perfectly with the 3D printed handle. So that is beautiful. Yep, I think I can scrape with that. Of course, before we do any scraping, we're going to have to grind the insert to the right radius and be set to grind to sharpen and resharpen it. And to do that, we're going to need a diamond grinder, which I don't have. I do have the diamond lapping plates that I showed in a previous video. And I think we're going to try to use the motor that I pulled out of the lathe when I did the VFD conversion and use that to build a diamond lap or a diamond grinder for sharpening these inserts. And we will start on that next time. Until then, if you're enjoying these videos, please give me a thumbs up. Feel free to subscribe to the channel and leave me a comment. I'd like to know what you think. Thank you for watching.